You return to camp carrying more meat than your group can eat today. The animal is fresh, the air is warm. Flies have already found it. By tomorrow, the smell will change. Soon after that, the food that saved your group may begin to poison it. There is no refrigerator, no freezer, no sealed plastic. So how did ancient humans preserve food without refrigeration? The first answer is not one invention. It is a chain of decisions. Eat what spoils first. Protect what can wait. Remove water, impossible. Use cold when the season provides it. Keep insects and scavengers away. And never confuse stored food with food that will last forever. Preservation did not stop time, it bought time. One of the oldest clear examples comes from Qesem Cave in Israel. The cave was occupied between roughly 420,000 and 200,000 years ago. Researchers studied the lower leg bones of fallow deer brought into the cave. These bones still carried signs that skin had been left attached during transport. Later, the skin was removed and the bones were broken open for marrow. Marrow is rich in fat and energy. Inside an unbroken bone, it is protected from dirt, insects, and direct exposure to air. The researchers combined archaeological marks with experiments and argued that people were storing the bones for delayed consumption. In effect, the bone became its own container. Not a metal can not a clay jar, a sealed package made by the animal itself. This does not mean every bone remained good for the same length of time. Temperature, humidity, exposure, and animal condition all matter, but the idea was powerful. You did not need to process every calorie immediately. You could carry selected bones back to camp and open them later. That changes hunting. A kill no longer provides only one meal. Some of it becomes a reserve. Meat was harder. Once cut from the body, it spoiled quickly. One solution was drying. Cut meat into thinner strips and more of its surface touches moving air. Water leaves the tissue. Microorganisms grow more slowly unless moisture is available. Sun can help, dry wind can help, smoke can help. But drying meat is archaeologically difficult to prove because the final product is meant to be eaten, and the racks, cords, skins, and containers used to make it usually decay. At Kharaneh IV in eastern Jordan, researchers found evidence that helps make this invisible behavior more visible. The hunter-gatherer site was occupied roughly 19,800 to 18,600 years ago. Gazelle bones were extremely common. Near a line of postholes, researchers found patterns in the animal remains that fit the processing of body parts useful for drying. They proposed that the posts may have supported a small meat drying rack. The interpretation is cautious. No strip of gazelle meat survived on the rack. But the combination of postholes, carcass bar patterns, seasonality, and ethnographic comparison supports the idea that meat was dried and stored there. Imagine the process. Fresh meat is cut away in long strips. The strips are hung where air can move around them. They are protected from dogs, birds, insects, and sudden rain. A smoky fire may burn nearby, not hot enough to roast everything. Just enough to dry, discourage pests, and make the surface less welcoming to decay. Some researchers have recently proposed that preservation and protection of large carcasses may even have been an early reason humans invested in maintaining fire. That is a hypothesis, not direct proof of million-year-old smokehouses. Still, it highlights the scale of the problem. A large animal contains far more meat than a small group can eat before it rots. Fire could protect that investment. Cold offered another solution. In freezing climates, meat could be stored in snow, frozen ground, shaded crevices, or cold caves. But natural cold is not the same as a modern freezer. A warm day can begin thawing. Scavengers can smell buried meat. Repeated freezing and thawing damage food. And ancient people had to remember where the cache was placed. The landscape itself became part of the storage system. A dry cave, a windy ridge, a cold hollow, a shaded crack in rock. The best technique depended on place and season. Fat required different treatment. Fat is dense energy, but some forms spoil quickly when exposed. Marrow protected inside bone lasts longer than exposed tissue. Rendered fat can be separated from water and tissue, then stored in a container. Dried meat can also be combined with fat to create a compact, high-energy food. Deep prehistory rarely preserves the bags, stomachs, hides, bark containers, or other organic packages that may have held such mixtures. The absence of a container does not prove the absence of storage. Often, successful storage leaves almost nothing behind because the food and its package are both consumed or decay. Plants created another challenge. Seeds can last far longer than fresh leaves or fruit, but only if kept dry and protected from insects and rodents. By about 11,300 years ago, people at Dhra near the Dead Sea in Jordan had built specialized granaries before fully domesticated crops appeared. The structures had suspended floors, air could circulate underneath. Rodents had a harder time reaching the food. Moisture was less likely to collect directly on the ground. This was not a hunter carrying one pouch of seeds. It was architecture designed around future hunger. The granary changed the meaning of abundance. A season of wild cereals could feed people long after the plants disappeared from the landscape. But storage created new social questions. Who filled the granary? Who guarded it? Who decided when it could be opened? Who received food when the supply ran low? Preservation was not only technology. It was cooperation, ownership, trust, and conflict. Fermentation offered another path. At Raqefet Cave in Israel, researchers studied stone mortar used by Natufian foragers around 13,000 years ago. Residues and use were indicated that people stored plant foods and produced a cereal-based fermented beverage using wheat or barley. The brewing was probably connected to ritual feasting. It does not prove that fermentation began mainly as a preservation strategy, but it shows that foragers understood a controlled transformation of plant food long before large farming societies. Microorganisms could change taste, texture, digestibility, and how long a prepared food remained useful. Ancient people did not need to see yeast under a microscope. They needed to notice that one method produced a predictable result. Use the same container, repeat the same steps. Wait the same amount of time, smell, taste carefully, remember. That is how invisible biology becomes practical knowledge. Preserved food was valuable because it reduced dependence on luck. A hunt can fail, animals migrate, plants disappear after a short season. Storms delay travel, injury keeps a hunter at camp. A bag of dried meat, a cache of bones, or a store of seeds turns yesterday's success into tomorrow's option. But storage also has limits. Moisture returns. Mold spreads, insects enter, fat turns rancid. A cache is stolen, animals dig it up, people forget the location. The safest strategy was rarely to preserve everything in one way. It was diversity. Eat fresh organs first. Share fresh meat widely. Dry some muscle. Keep marrow sealed inside selected bones. Use winter cold when available. Store dry seeds away from damp ground. Ferment some plant foods. Place reserves in more than one location. If one method fails, another may survive. This is the counterintuitive answer. Ancient humans did not preserve food by making it permanent. They preserved it by understanding which foods failed slowly, which failed quickly, and how to move each one into the next category. Fresh meat became dried meat, a whole limb became stored marrow. Wild grain became a protected reserve. Plant mash became fermented food or drink. Surplus became time. Modern refrigeration makes this knowledge easy to ignore. You place food behind a door and expect cold air to protect it. Ancient humans had to read every sign directly. Smell, texture, moisture, insects, weather, season. They had to know when food was safe, when it needed more drying, and when it had become too dangerous to eat. You look again at the fresh carcass in camp. The group does not treat it as one pile of food. Some parts go directly to the fire. Some are shared immediately. Thin strips are cut for drying. Lower leg bones are left closed. Fat is collected. Nothing is preserved forever. It does not need to be. The goal is to make today's animal last beyond today. And in a world where the next hunt might fail, a few extra days could be the difference between hunger and survival. If you enjoyed this journey into the distant past, subscribe for more stories about ancient humans and human evolution.